Oh boy, so I finally built my dream water-cooled hardline system, and good people, I can totally see how this becomes an expensive hobby. Now in the previous video we went over all the components and all the initial hardware installation, plus for the first time ever I disassembled a graphics card. And so many of you have mechanically vocalized as to why we didn't just wait for 3rd gen Threadripper, instead I went with my 2950X, and this is why.
They'll actually be using a new STRX4 socket, and they'll require a new generation of motherboards based on the TRX40 platform. That means absolutely no compatibility with 1st or 2nd generation Threadripper CPUs or motherboards.
I didn't want to wait any longer because I just wanted to build the system, because otherwise you'll constantly be waiting. So let's pick up where we left off. Do you have any expectations for the build we're doing now?
The build that we're going to be doing here is probably not going to be the most simple build that we could have done, because we'd like to see you doing hard tubing and really make an over-the-top system. So it is going to take some time, it's going to take some learning, and this is probably not a beginning entry type build, but it is something that will end up looking like a true masterpiece.
Now, before installing the graphics card, it is recommended to complete as much cable management as possible, which is what HP helped me with. One trick we did here is to install the Commander Pro and the lighting node behind the plastic front panel, so it is not in the 2nd chamber, and this helps to minimize cable clutter. Now, doing cable management is one of my least favorite things when it comes to building a computer. Even if it's something basic, it's just like I get stuck in seeing all the cables and not knowing exactly how to route them. But luckily, we have the 2nd chamber with a 680X, so all the cables get basically cluttered there, and the main section with the system remains clean. HP, on the other hand, loves cable management. He finds it therapeutic, and it's all about patience and basically collecting all the cables and using zip ties and bunching them up in their own clusters. We installed the res pump combo right behind the Commander Pro. It's a great location for tube routing, and finally I mounted a graphics card. We intentionally wanted the vertical orientation for best showcase of the block, and to keep things stable, Hans-Peter 3D printed a platform that fills the space between the riser cable and the fans, so the whole thing is completely stable. So guys, my first hardline tube is complete, thanks to HP for all the valuable information that goes into making this possible. The actual process is fairly simple in terms of heating up a certain section that you need to bend and making sure that you heat up the sides as well. But then you understand the complexity of making sure that the bend is properly complete and everything aligns to where you need to align, because you don't have much wiggle room. And you really appreciate all the guys who do water cooling and do really complex bends that goes in and out of a system. So now it's time to show you how this is done and actually start to do our tubes for this sick build. So the first thing we do is dip the silicone tube in water. This way it slides into the tube without resistance. We fire up the heat gun and concentrate the heat in the area where we want the bend to happen, while being careful not to be too close to the heat source, as that will just melt the tube and form bubbles, while also not being too far where the heat will just take forever to soften the tube. Once the center point starts to become softer to a point where slight pressure bends the tube, we start to heat up a larger area in this side-to-side motion while still rotating the tube. And we do this because the sides also need to be soft around the main bend, otherwise the tube might kink. Now for our layout, we are using many 90-degree bends, and one trick is to use a table with a corner and to align that 90-degree bend perfectly, hold it in place for a minute for the tube to cool down and harden. Then we can remove the silicone piece and observe the bend to make sure that we don't have any bubbles or kinks. And to my surprise, I did not destroy a single tube throughout this entire process. Very good guidance from HP, nicely done. Now the more challenging thing was just around the corner, with measuring where the bends need to happen and how long the tubes need to be. You realize just how much precision is necessary when it comes to hardline tubing, but you also realize that majority of it is mainly eyeballing it and learning from your mistakes. So for example, HP prepared a few tubes that were just a few millimeters too short, and that gave me a perfect blueprint to follow. And that's the general process too. You make a bend, see if it fits. It might be a little bit too short, or the bend needs to happen a bit earlier, or it went too far. You redo that and use the earlier pieces for guidance. So for example, the 90-degree bend that I made for the top tube was 1 millimeter too short. Luckily, we had some flexibility by moving the radiator to fit our tube alignment perfectly, and this way nothing seems off angle, and the first tube follows vertical and horizontal lines perfectly. And finally, it's all about installing each hardline tube one at a time. My top tube had perfect ram clearance, and it was my first proper bend that came out very well. So with confidence, I moved on to the second tube. And here again, the 90-degree bend was just 2 millimeters off, meaning we could start from scratch or heat up that section again and try to reposition where the bend happens. And this is where HP stepped in, and we did it without destroying the tube. And then I was all on my own, seeing where the bend needs to happen, cutting the tube, measuring again on the opposite end, cut and fit, and you just keep going until it's like a perfect alignment. Once it's 100% you're satisfied with, you move on to the next tube. Now the area behind the motherboard is normally done with soft tubing, but it was great practice before we get into the main section with GPU tubes, as those were the most challenging. So for one, measuring something that you cannot see or is not easily accessible is very difficult. And so that's the case with GPU fittings because they're facing towards the motherboard. So HP had this brilliant idea to recreate the same fitting layout at the front of the block, and this allowed us to get the proper length measurement for that section of the tube from where it went into the bottom radiator. The most rewarding thing for me was finally inserting all the tubes, securing all the fittings, which were quite difficult to get to because of awkward spacing. And I have a new appreciation for all ITX custom loops because even reaching the fittings for the top radiator and the bottom radiator, like the ones that are in the back, was a bit challenging. But imagine working with something that is super cramped. Respect.
I think for me the most frustrating things is to get the hard tubing runs the exact length, because I'm very particular about that nothing is out of angle. So if a hard tube run, for example, is 1 millimeter too long, then it'll look crooked in my eyes and I'll have to redo that entire run again. Taking care with it and just spending the extra time is just what it takes. Like, people will have to be comfortable with learning how to do, for example, a complicated run, because you will mess up the first time, maybe also the second time. So it is a learning curve and an experience to do.
The next thing for me was a big surprise, doing an air leak test, basically blowing into the loop, and if pressure is good, you'll feel no air is leaking. And this is that preliminary step to make sure that you don't have like an open port somewhere, and you don't do this with water, you do it with air first. Because if you blow into it and you have this massive resistance where the air just cannot travel anymore, that's a good sign. Whereas if air would just escape, you know, you might have forgotten to put a plug somewhere, or maybe one of the fittings is loose or something like that.
Nothing goes through. Yeah. Time to fill. Oh, I can see it. It's going. Is that supposed to happen? Oh, yeah, I see it. What? Oh, yeah, I can see it. Oh.
And finally, this is a very special moment in any water cooling project. And all these bubbles and initial foamy water is actually very cool to witness, as it highlights the water path through the blocks. And it took about 2 days for all the bubbles to disappear. And if the built-in flow indicator wasn't on the GPU block, the flow would appear static. And so here's the finished system.
I think one of the most surprising things was how quickly you actually picked up on bending the hard tubing. Because I've seen a lot of new beginners doing this stuff, and like the norm that I would say is that you would take the first couple of meters and ruin those in regards of like bad bends or measuring wrong. But as I also mentioned, like that we only use 2.5 meters, like that's pretty impressive for a first timer.
And the fact that HP was there throughout the entire process was a relief and giving me the basics behind tube bending, leak testing, cable management, and guiding me through the initial setup with IQ, as all the fan RPM lighting and temperature monitoring is done there. And we installed a few temperature sensors, one for the reservoir, one in GPU inlet, one in GPU outlet, and one ambient sensor for either case temperatures or external temperatures, just so you can monitor what's happening cooling inside your loop. And let me tell you, my friends, the temperatures are incredible. My 2080 Ti Strix is overclocked to almost 2100 megahertz with a slight overclock on VRAM 2, and maximum temperatures we're seeing are in low 50 degrees Celsius, which is just crazy, while the Threadripper 2950X idles around 37-38 degrees Celsius and spikes up to mid 60s under load, and all 16 cores have just enough cooling capacity to reach 4.1 gigahertz and beyond. That is the power of water cooling. And the last surprise are noise levels. So my fans are currently set up to not even spin unless the water temperature in the reservoir hits above 34 degrees Celsius, which is like at idle situations right now, we're not spinning, so the system is completely silent, and the fans do start to ramp up gradually as the water temperature rises, so you don't get those like massive spikes in RPM for the fans when there's load on the CPU. The pump unfortunately is audible when the RPM goes above 2200, and it has a slightly higher pitched noise than I like, and that is literally my only complaint with the system. My God, I sound so spoiled.
In regards to what I think one of the most challenging thing was, like, it was quite evident that doing the whole cable management and like getting everything crammed in and zip tied up, I think that probably took most of the time. And installing all the other different components went pretty fast. So next to the tubing install and cutting the tubing and measuring them out, I do believe the cable management and that stuff was definitely one of the most challenging things. If I were to do one at home in this case, then I'd probably be copying this layout because it just works so well.
I still can't believe I built it and it's so epic, yet it still does not run Red Dead Redemption 2. And since I haven't ruined any tubing and Corsair sent me 9 meters of hardline tubing, I'm thinking I should do another system. Alright guys, I'm Dimitri, thanks so much for watching. Check out this other relevant content and I'll talk to you in the next video.